Hello, everyone. I wanted to give a Saturday update on 3i Atlas. Let me just state right away we don't have any images, nothing's come in yet. We don't have a whole lot of information. We're still waiting on it. I'm really anticipating anything that we can take a close look at is probably going to be tomorrow, or because of the shutdown, could be later. But just wanted to go over a few things because the Interstellar Comet 3i Atlas did successfully make its closest approach to Mars yesterday, October 3rd, at approximately 29 million kilometers, so about 18,000 miles away from Mars. It's a historic milestone as the third confirmed extrasolar object after Oumuamua and Borisov to pass so near a monitored planet like Mars. This alignment allowed for a multinational fleet of orbiters to capture unprecedented data that we're waiting on right now. Though no official images or spectra have been publicly released due to ongoing U.S. government shutdown impacting NASA operations and just transmission speeds, through our solar system. Pre-shutdown planning ensured observations proceeded, but processing and dissemination of the data is going to be delayed. Early community processed raw data from Perseverance shows a faint streak consistent with the comet's position, hinting at a coma and tail, but high-res details await official drops. And right now, the FTP sites don't have anything in them. So from recent reports, we know that all the planned assets, including NASA's MRO HiRISE, Perseverance, MAVEN, Curiosity, and European space agencies Mars Express, HRSC, Omega, and SpyCam, and ExoMars, which is the Cassis and Nomad. But also, we hadn't talked about this before, but China has something up there also called MORIC, and the United Arab Emirates has a vessel up there also called Hope. EXI Emirs EMAS acquired data starting as early as October 1st. So HiRISE's 30 centimeter per pixel resolution could pinpoint that 5 to 6 kilometer nucleus. While the spectrometers targeted outgassing for composition clues, we're waiting on that data. That's going to be fascinating too. The closest spacecraft comet distance was about 30 million kilometers, which is far sharper than the Earth-based views that we've got. And that view is now fading. And we're going to talk about that in a minute because there's been kind of a subtle change about what we're going to see in December now. Harvard's Avi Loeb recapped recently, I think it was yesterday, that there's deal breaker traits in this, that the mass is too big. It's 3 to 5 times the size of previous visitors. It's very heavy. The luminosity, the trajectory with the ecliptic alignment, the near planets timing, the fact that it's coming in on our planetary ecliptical plane and it's coming this close to planets, he's saying no way. There's no way that's just naturally happened. He speculates a natural dense protoplanet seed from the Milky Way, possibly artificial elements with a deliberate path and non-gravitational boost. There's been no breakup or flare yet from all this gigawatt solar heating. So all those things he's pointing to, saying something's artificial with that. NASA's raw Perseverance Mastcam Z images, they also call that camera Sol 1643, processed by Simon Schwab, showing a transitioning object, not Phobos, matching 3i Atlas's predicted path. It's faint, it's got a reddish coma, a 3 arcsec tail elongation, but the public is getting frustrated over the top secret holds since October 27th. And Tennessee Representative Tim Burchett even questioned NASA's silence. He went on Newsmax last night and said the pre-shutdown timing is causing a lot of conspiracy theories to come out, right? Like, do they know something and they're not telling us? That's what the speculation is. He is calling for UN oversight. He's saying we need to have a higher body because there's something going on in our government. They're not telling us something. That's his perspective. We're now expecting to get data from the European Space Agency, China, and the United Arab Emirates first before we get anything from NASA, because the NASA FTP has been silent for high rise. So we haven't seen anything come in from NASA based stuff. Just a projection forward, the next big date is the perihelion. That's going to be somewhere around October 29th to 30th at 1.4 times astronomical units. So that's going to be inside Mars orbit. The post perihelion activity will be viewable by ESA's, that's European Space Agency's JUICE, which is on Jupiter, November 2nd to the 25th. There's going to be a lot of analysis going on there. It could be a tail sampling also. I'll dive into that in another video. The closest approach it's going to take to Earth is in early December, 1.8 astronomical units, but the intensity of the brightness is starting to fade. So the flyby underscores 3i Atlas's rarity as a cosmic relic from the galaxy's thick disk, they're calling it, potentially revealing extrasolar planet formation gaps. The data releases that could take weeks now could confirm an ice rock mix or stranger things that are going to be considered a fluke or possibly engineered. So we know that this is not your average comet. It's interstellar. It's massively dense. It's on a path too perfect to ignore. NASA's robots out there, they've got ringside seats. We're waiting for the footage. This is a very important analysis going on right now. And some of the core things is like, so far the sun's energy just hasn't seemed to affect it, including that coronal mass ejection. But we'll get a better idea about that when the photos start coming in. NASA's MRO high rise should give us the sharpest images ever, 30 centimeters per pixel for the nucleus size. Maven is going to be looking at it from an analysis, like looking at UV, and you'll see like time-lapse streak photos where it's analyzing that, and we'll be looking for that red tail or the green, and we're trying to figure out what all that means. There's going to be plume analysis. Is this rock? Is this ice? Is it exotic? European Space Agency is going to help out with that with their Omega spy cam, looking for chemical fingerprints. China's MORIC and UAE's HOPE could give us some additional data also. So this is really the first multinational stakeout, and it's kind of opened my eyes. I always think a space program is just NASA and maybe a little bit of Elon in there, but really other countries are out there too. Of course, who's putting their stuff up there. They're not 100%. We still own the space program, but we definitely have an international effort out there. So out there right now is MRO from NASA, Mars Express, EXO. Mars Express is from European Space Agency. ExoMars is European Space Agency. That's the Cassis Nomad. Maven is NASA. China has a MOIRC, and it can look at thermal activity, infrared spectrum. And then the UAE has the HOPE out there in EMERS, and it can do imaging plus infrared, and it can look at UV data. So a lot of interesting stuff will be coming along. Avi Loeb is still, saying that he thinks it's a anonymously massive object that weighs at least 33 billion tons. It's luminous. It's resilient to solar storms. Could be protoplanet seeding, formation gaps. It could be alien because the path screams design. It'll be interesting. Did it eject anything to Mars? We don't know. I don't think so. But look, Avi Loeb is calling this a black swan event. That's how big he thinks this is. And it's not helping that we're in shutdown and now NASA's kind of quiet. The FTP site for high rise is empty. People are getting frustrated. What's up with the data embargo? Let us see the images. We should see Perseverance shots first. Maybe see a transit active coma. We'll see. But then the stuff starts going to come in from ESA, China, UAE, a lot of stuff coming. And then JUICE with the Jupiter is going to get a lot of the good optics starting in November. The Earth flyby is coming up too, but it's starting to fade, especially post perihelion. And there's been some confusion about whether ground-based telescopes can observe the interstellar comet in early December, given its fading brightness and increasing distance from Earth. So I just wanted to talk about that a little bit. The current status as of today is 3i Atlas is currently at a visual magnitude, they're estimating of 12 to 13, which is visible to large amateur telescopes with like a 8 to 10 inch aperture under dark skies. It's approaching perihelion, the closest point to the sun, on October 30th, and that's when the brightness is expected to peak. And then, outgassing and coma-tail activity, like it should, well, by early December, it'll be nearing the closest approach to Earth, and the brightness is projected to fade as it moves away from the sun post perihelion, with reduced solar heating and outgassing. This makes it a challenging target for ground based telescopes. And no one was really, no, I shouldn't say no one. I wasn't thinking about that. That it would fade as it gets further away from the sun, and that could affect our observations. So, but did a little bit more research, and I'm starting to understand it's not a perfect situation, and that's part of what Avi Loeb is talking about. Some of this is just bizarre, the timing of it all. When we get eyes on it again, it's kind of the moment's kind of past. Scopes with an aperture of 10 to 14 inches still might be able to detect it under excellent conditions. So a dark, moonless night, high altitude, but it's going to require long exposure astrophotography and sensitive CCD cameras to capture the faint coma or nucleus. That's why we couldn't aim it at the sun, because the sensitive equipment would have got burned up. But what we're talking about is we're going to have to take the picture and hold everything real still, and we can't get enough in a moment. It's going to be a long exposure, and we'll put all that together. I don't know what kind of optics we're going to get, but facilities like the Gemini South telescope or the Very Large telescope can still track it. They can potentially resolve the nucleus if it's 5 to 6 kilometers, and faint tail features. So not all's lost. It's not going to be super clear in early December, but it will be beyond the reach of smaller setups. Atmospheric interference could mess with this. Light pollution, weather, the comet's low surface brightness starts to get diffused. It could make visual observation difficult. By mid-December, it's expected to drop in magnitude, becoming effectively invisible to most amateur setups and requiring deep sky imaging systems. So there were some earlier projections that 3i Atlas was going to be brighter pre-perihelion, or optimistic assumptions about its activity. But now we're starting to understand that it's probably going to fade. It's probably going to be a rapid fade after October 30th, and we're just going to lose sight of it. But Jupiter's still going to see it, our equipment on Jupiter. But just letting you know, the best stuff we have is our ground-based observations on Earth, and that window is kind of past. However, Jupiter's icy moon explorer, that's from the European Space Agency, it's called JUICE. It's en route to Jupiter, and it's ideally positioned to observe 3i Atlas from early November through late December. And during this period, the comet will be post-perihelion with a potentially bright coma tail peaking around November 25th as it crosses Jupiter's orbital region. JUICE's Janus camera, which is a high-res imaging, and it also has onboard UVS spectrometers, will capture detailed color images and chemical data, offering insights into the outgassing post-perihelion. We're going to be looking for water. We're going to be looking for CO. We're going to be looking for organics. NASA's Juno spacecraft is orbiting Jupiter right now. It may provide some supplementary observations if 3i Atlas passes within its field of view, but this is less likely due to Juno's polar orbit focus. It's just what it was deployed for. The Lucy mission is en route to the Trojan asteroids, and ESA's Hera, if aligned, could also sample the comet's dust tail into early 2026, but JUICE is the primary player. But it's going to be fascinating if we can capture some of the dust trail. We'll get a lot of analysis off that. Space-based platforms like JUICE avoid Earth's atmosphere. There's no light pollution issues, no weather issues. It offers clear, high resolution views, but it's far away, and we don't have that immediate control of it, and then we have to try to get the data back to us. And you know how things go wrong and with technology and transmissions, but it's probably going to be sharper data than our ground-based scopes in December. In a nutshell, that's what I'm telling you. Like, we thought we were going to get some really good images in December, but now we're thinking maybe not. But early December is likely the last chance for ground-based observations. It's a tough ask. Only advanced amateurs with large scopes, like 12-inch, or professional observatories with adaptive optics will catch it. And even then, it's mostly for imaging. It's not going to be a visual observation. By mid-December, it's going to be too faint, with a magnitude of 16 for most setups. The Jupiter-based equipment, JUICE, is going to be far superior for December. JUICE's November to December window captures 3i Atlas at peak tail activity, post-perihelion with high-res imaging spectroscopy that ground scopes can't match. Data from JUICE will be critical for scientific analysis for composition, non-gravitational acceleration, and it may reveal further anomalies like those speculated by Avi Loeb about a dense nucleus and possible artificial origin. So, in a nutshell, ground-based telescopes have a narrow fading window in early December for dedicated observers with advanced gear, but the best shot for meaningful data and visual lies with JUICE and the other space-based assets and the data we're going to get from the Mars assets. By late December, 3i Atlas will be effectively lost to Earth-based observers as it recedes toward a magnitude 17 and beyond. We will not be able to see 3i Atlas in the latter part of December. So, and here's the thing. So you can see the orbit as it's going towards Jupiter here. But here's something. Let me pop this up real quick. If I can get it to work first time. I want to show you this brightness curve. Let's see. I had AI develop this for me. Right, here is the brightness curve. Now, as you can see, here's basically now, and you can see the brightness curve is going up, but that's because it's approaching perihelion. The closest it gets to the sun, the brighter it's going to be, and then there's the steep drop off. By early December, when we can see it from Earth, the brightness has faded quite a bit, and it just keeps on fading. So I just wanted to show you that. I fed all this data in AI. This is what spit out. A great little chart just to kind of observe this. But in a nutshell, early December is going to be our best bet. It's a fading bet. And if we have bad weather or something like that, it's not going to happen. But the Jupiter equipment's got our back. And then we're waiting on the Mars stuff. I'll go live tonight. We'll talk about what we see so far. Maybe we're not going to see anything. I still hold out that maybe there's going to be a press conference next week. But all eyes on the sky on this one, y'all.